So we're going to talk about specifically when do you pool or combine, when do you not. We're also going to talk about when do you use a match pairs versus when you use a two sample. So these are some bigger issues that students have throughout the year. So, and then also I want to get back your quizzes and let us go over those. Meg, you'll need to make that up, and the other person is Brianna. So she is not here yet, so or back yet. So I don't know if you want to all get together, okay, to do that. All right. So let's talk about when do you pool and when do you not pool. So when doing two sample T procedures, should we pool the data to estimate a common standard deviation? Is there any benefit? Are there any risks? Okay. So we never pool for means, and I'm going to explain all of this to you guys. We never pool for means. Now, there's a formula on the formula card called the equal variances formula. I'll show it to you. And basically it says here that we don't ever use it, nor do you need to understand how to use it. So you're probably wondering, why is it on the formula card? Well, it's because when AP Statistics was first introduced in the first year of testing, they didn't have the TI-84s, they didn't have any calculators that could do degrees of freedom as we do now. So there used to be a different approach. Y'all don't even need to know this formula right here, okay? That is called the equal variances formula. If you're ever reading the book and it talks about it, you never need to use this, nor do you need to understand it. But I'm pointing it out because it is in the same area as the one we're going to talk about today. Okay. So the test that we use will actually work for both equal and unequal variances. So we're going to get the degrees of freedom from the calculators, what's going on there. Okay, so we never pool for means, ever, ever, ever. And I'll talk about why in just a second. So what about a two sample test for a difference in proportions? Why do we pool for this test? Yes. We always do. We always... if I could spell. We always pool for proportions, but only when performing a test, not for an interval. This is because we are assuming that P sub 1 equals P sub 2 from the null claim. Okay, so we always approach it the same way. We're always assuming that the null is true, no matter what in these. And the formula for standard deviation uses P sub 1 and P sub 2. So that's why we have to pool, because we're assuming they are the same thing. Okay. And therefore, P sub 1 and P sub 2 are used in the standard error formula for P hat sub 1 minus P hat sub 2. So I'll go over that in just a second. Therefore, we must compute the combined pooled proportion. So we always pool for proportions for a test only. Okay, so y'all probably realize this. So far, we pretty much have 4 big concept areas. Let me kind of just summarize that for you. Basically what I mean by this is we have tests and we also have intervals. Y'all agree? Yes. So far we basically are doing P's or we're doing means. So those are our 4 big concept areas. No, this is just kind of more of a conceptual thing. Now, it's more complicated than that, isn't it? Because for P's, we can do a 1 sample or a 2 sample. So 1 sample versus 2 sample. And we do a 2 sample, we're really talking about a difference in the proportions, right? Yes. Means are the same thing. We have a 1 sample versus a 2 sample. And there's only one time that we're going to pool. So basically, we have 4 big areas, but you could almost double it because you got your 1 sample test and intervals, you got your 2 sample tests and intervals. Where is the one place where you would pool? Right here, only for the 2 sample. So here's where you pool. Obviously, you're combining, so you need 2 of something, so it has to be for the 2 sample. So for the 2 sample test. Not for intervals ever, and not for means ever. We never pull for those. So is that making sense to you, like when you pull? And I'll explain why that's the case in just a second. Is there anything else y'all can think that we're missing?
What is pooling?
Yeah, I guess that's a good thing to
P hat sub C. We learned that a few days ago. Y'all actually know what pooling is. It's combined. You do not because you have not been here, but we'll talk about it.
Yeah,
Now, that's
How
called
would you
pooling.
How would you
You cannot. There's
So, like,
you would have to average. You'd have to average the X bars,
Oh,
and it
okay.
doesn't make sense. And I'll explain why in just a second. Okay, so I will add this in here. Isn't there really 2 different things we could do for means? We can do our Z's, or we can do our T's, right? What about our P's? They are always Z's, right? So these are all Z's over here. Our P's always use Z's. So any test or interval,
This is why we came to the door open.
any test or interval for proportions is going to use Z's.
No, I don't want to hear James.
Okay.
Our connection to the outside world.
Then mean, y'all please, shh. Means we have Z's or T's, but usually we have what?
T's.
T's. Very good. Usually we have
Don't
T's.
know the same.
Yeah, because we do not know sigma. So this is when sigma is known, which is very rare. And if it's a 2 sample, you'd have to know both sigmas, obviously. Okay, there's one other thing, and we're talking about this today, and I want to show you where this fits. It's something called the match paired T procedures. It fits here with the 1 sample. So the 1 sample is really going to be where we put the match pairs T procedures. And that's a whole other topic for today. Yes, Gigi?
Why didn't we pull with p-test before?
Because before we only had 1 P.
Oh, this is all for 2s.
This is all for 2s. Yes, very good question. Okay, very good question. So when do we pull? We only pull for proportions, a difference in proportions for the test. Why? Because we're assuming that P sub 1 is equal to P sub 2. So that's what we're assuming. And here's the bigger picture. When I use the formula, like this is our formula card, for 2 sample, isn't this what we're talking about when we're talking about the standard error for the, right? Standard error. Do you see P sub 1 and P sub 2 are both in this formula? So when we are assuming P sub 1 equals P sub 2, we have to adjust this and use the combined proportions here. And I'll show you what that means in just a second. Whereas when you look at the sample, the difference of sample means, standard deviation or standard error formula, guess what? X bar is not in here. So yes, we're assuming that the null is true and that the mean should be equal. But the means are not even used in the formula here, whereas the means are used in the formula there. That's the difference. The P's are used in the formula here, sorry, and the means are not used in the formula there. So in other words, we are assuming, when we do a test of significance, we're assuming that the mean from the first population equals the mean from the second population. It doesn't have any impact on this, though, because mean is not in the formula. Whereas down here, when we assume P sub 1 is equal to P sub 2, they are in the formula. So I have to use the combined proportions. Okay, does that make sense to everybody? Can anybody kind of summarize it in your own words? I had somebody do that last period, and then people kind of started to get it.
I don't know.
Jay.
I don't know if I understood it.
Steven. Yeah, Jay, I'll get it.
Anybody? Anybody?
Miss Ryan, what are you asking us to summarize?
Summarize why we pull for proportions but not for means when we're doing a 2 sample.
Means don't have
Oh, that's
proportions.
that's what I'm saying. Proportions. I mean, see that. Yeah,
Wait, so
this
why you
can
pull
combine
for proportions and not what?
And why not for means?
Yeah, not means.
You don't use it.
Means don't
there's no.
Okay, let's go back to the drawing board here.
You don't use it like in the formula.
Okay, it's not in the formula. In other words, here, what are we assuming? When the test, we're assuming P sub 1 equals P sub 2. What are we assuming down here? Mu sub 1 equals mu sub 2. These are kind of our basic starting points for both of those. So when we're assuming this is true and we're using the formula is this. And remember, we do P sub 1, 1 minus P sub 1, all over N sub 1. And then we do the same thing with what? Our P sub 2's. So if we're using this as our denominator, remember this is our denominator of the test statistic. The problem is if I just use P sub 1 and P sub 2, do you see I'm not really holding true to this assumption? I'm not holding true to this assumption. So to hold true to it, I need to come up with a combined P hat.
Oh,
So
okay.
I have to combine the P hats because we're saying they're the same.
Oh, and
So
you
we want to
don't
use
do
the
that.
same proportion.
Well, then,
Why do we not do it here? Because yes, we're assuming this is true, but the standard error formula is what?
Not P sub
Standard
one.
deviation.
Deviation of the first one squared over sample size of the first one plus.
Yes, we're just using this right here, correct? And we won't know sigma, but we would use S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2.
Wouldn't S sub 1 and S sub 2 have to be the same?
They do not have to be the same.
Why is that the case?
Okay, y'all hold on. Let me answer his question. Do you see that we're assuming the means are true? We're never saying that these have to be the same. Up here we're saying the null is true, meaning the proportions do have to be the
So
same.
The spread can be different.
Yes, the spread can be different.
The spelling is the same. Okay.
And basically, so when you see here that these two are the same thing, in the past you did have to use a different formula when you knew that variances were equal. So you're on to something, Ben. It's not that the variances, like that's not an issue sometimes. We don't have to worry about it anymore because our calculator gives us the degrees of freedom that will work with it. So we don't have to even worry about it. So you'll never use this formula for equal variances.
Okay.
Okay, now let me kind of summarize some stuff and I think it'll help you out. So now, when we combine our P's, this is what we're talking about. P hat sub C is going to be what? X bar sub 1 plus, not X bar, X sub 1 plus X sub 2 over N sub 1 plus N sub 2. So what are we basically doing here? When we take X sub 1, X sub 2, add them together.
Distance formula.
You find a linear average. Well, you find the average proportion.
Yes. So isn't this really saying total successes over what?
Total.
The total in the samples. The total. And didn't we do this, guys, with our basketball example? Do you remember that? And our little simulation we did in class? Okay. Y'all connect all the dots. You're doing great. Okay, good. Now, so we are also assuming that mu sub 1 equals mu sub 2 from the null claim, but these are not used in the formula, so we don't need to combine or pull for the means. There'd be nothing to combine or pull, so there's nothing to do there. Okay, I think that makes sense. I hope that makes sense. Now, so that's one concept. When do you pull? Only for proportions and only for when you're generating a test or running a test for the difference of proportions. One time and one time only. And the calculator does it for you, actually. Okay, now, the next big topic is what is the difference between a two-sample T procedure and paired data? Okay, should you use it for paired data? The answer is no. Why not? We'll talk about it. And how can you know which procedure to use? So let's talk about this. So no, if we have matched paired data, we're going to use what? Matched.
The one sample.
Yes, very good. Matched pairs or paired, and it's going to be whichever test or interval you're trying to construct. So it would be T procedures. That's kind of just what we call it. Match pairs T procedures. But guess what? That's really just a one sample T test or T interval.
It has it right.
Yeah.
Oh, look at that. I added that. I forgot. Okay. So there you go. So, and we would look at what? Well, if we're doing a matched pairs, one sample, wouldn't we would look at the average of all the differences, okay? So we would look at the mean difference, and I'm going to kind of design something for you in just a second to help you. As opposed, if you have a 2-sample test or interval, we would look at the difference between the means. And I just kind of abbreviated there. So if you're doing a matched pairs t-procedures, you're really just doing a 1-sample t-test, and you're going to have 1 sample, you have 1 average or 1 mean for that sample. So let me show you something. Pretend for a second I'm looking at cholesterol level, okay? So say I am doing a little experiment where I feed people candy bars, okay? And then, so I do almost like a before and after type scenario, and I'm looking at their cholesterol level. And so say I have Ralph, and I have John, and I have Sue. And I'm going to do this for all 3 of them, okay?
Ralph, can we change his name?
Ralph, how about Ralphie? Okay.
Ralphie.
So I'm going to take a before and I'm going to take an after. And I'm literally just making it these values. These may not make any sense whatsoever. So say Ralphie before has 20, yes, however we're measuring it. And then say after he has 30.
Oh, that's not good.
Why do you
That's
know
like
it's
on board children.
We have no units. How do you know it's high or not?
Well, that for the sake of this, it doesn't even matter. Okay, then what about John? Say he went up from 15 to 16. And then what about Sue? Say she was a nice 10 and she went up to 14. Okay? Now,
I do too.
would it make sense to do this as 2 different samples, like a before sample and after sample, or does it make more sense to maintain the matching between the before and after for each person?
What?
Huh?
Maintain the matching. Very good. Maintain the matching.
Yes.
Oh, yeah.
So what I would do is I would say 20 minus 30, or I could do it either way. I could do 30 minus 20. So this is going to give me a difference. So I get 10 here, 1 here, and 4 here.
So you're saying rather than averaging all of their different before and afters, you're saying that you just keep each one of the individual differences.
Yeah.
And then what do you do with the differences?
Okay, let's talk about that. So some of y'all have not even gotten this concept, guys. Are we paying attention?
Yes.
So I'm going to basically say after minus before, because then I'm dealing with positive values if I'm suspecting it's going to be an increase. So what would I do with these differences? I would average them. I would find the actual sample difference, like the X bar for the differences. So I'd average all of these. So no, I wouldn't be looking at the average from sample 1 and sample 2. We want to maintain the matched pair scenario, and we want to create one sample or one set of data which represents the differences. And then we would average all those differences.
This one was discussed.
We'll look at it
When we
sometime,
get back.
yeah, when we get back.
Yeah, like, because we're going to forget all this.
Okay. So should I just not teach before a break ever? And just like say, we'll just learn it when we get back?
I wouldn't- I mean,
Yeah.
I just sent that homework over.
Okay.
That option.
So guys, a 2 sample might look a little bit different. So if I had a scenario where I didn't need to maintain the matching, what I would do is I would say 20, 15, 10, and I would get the average of the first sample. Okay, so it'd be like X bar sub 1. And then I would do 30, 16, and 14 and get X bar sub 2. So I would actually say for my estimate, it's X bar sub 1 minus X bar sub 2. So here, I'm getting a statistic that is the average of all my differences. Here, I'm getting 2 statistics from 2 independent separate samples that I find the difference between the 2. So that's the scenario. Okay, so here I'm averaging the differences. I have one, it's basically one sample. It is no different than our one sample t-test or t-interval. It is no different. The reason we use this notation, though, it's the match pairs notation.
Don't you get the same answer though?
No.
These two would not be the same at all, no. Could they be close? They could be.
Wait, would one not just be negative and the other positive value depending on how you subtract the means?
Yeah, I probably would want to do x bar sub 2 minus x bar sub 1. It changes everything when you look at it differently, because if you need to maintain this matched relationship, you want to treat it as a match pairs T procedures versus as here we're definitely dealing with two different samples. Okay, so how are you going to tell the difference? Do y'all see why this is a big topic and we need to talk about it? Gigi, yes.
Did you put like the two sample one where it's like you did the other one where it's like the Ralph Johnson over it is like the two sample means?
It's the difference between the means right here. Difference
No.
between the means.
Can you use that same story but make the two different tests, or how would you know which one to do?
Okay, so say I had two treatment groups, just totally random assignment to the treatment groups. There was no blocking, no matching, nothing up front. It was complete. Y'all remember the completely randomized completely randomized design, where you have your subjects and immediately they get randomly assigned to the treatment groups. So I'd have two treatment groups. There's no relationship between the two treatment groups in terms of like I need a match of some sort. They're just a group of people, a group of people. And if that's the case, then treatment group 1, let's say I'm measuring their cholesterol, I could average their cholesterol. And then treatment group 2, say I'm averaging their cholesterol levels. Then if there's no matching going on, I want my estimate to be the difference between the two. This is both of these are very common experimental designs, and that's what we're actually going to do as an activity today. Yes, Dalton?
They're actually the same thing in this example.
They may be in this example, okay? But still, you still have different formulas. It's a totally different formula. No, it's a different formula. Because you would use this as your standard for the two sample. This would be your standard error. Whereas you would use this for the standard error for your match pairs. You do get different results, okay? So how are you going to know which one to use?
You guess.
No, you don't.
Depending on your standard deviation.
Okay, y'all listen. So these are some questions to ask to determine whether you have a match pairs or a two sample. Could I create a label for the rows? So right here, when I gave Ralphie, John, and Sue, do you see that those rows have labels and it's meaningful? I want to maintain that matched relationship. This is a good example of a match pairs design.
So you match pairs when you have like important people. And that it's just like, oh, there's 30 different apples. You know.
Okay, yes, you're on the right track there. Okay, also, would it mess up the data to scramble one or both lists? This is a biggie. This is a biggie. So if I scramble this data, it's going to give me, it won't give me a different like average, but I'm losing part of the information. Basically, if someone already has high cholesterol, maybe they respond differently than somebody that has low cholesterol. So you want to know a before and after direct comparison. Finally, were the subjects matched by some criteria? Guys, were the subjects matched by some criteria? Okay. So if they were, such as remember we did the block dogs activity? And y'all remember what a block is?
Yeah.
A block you can group on more than one thing, but a match pairs you only have two things in the block. So a match pairs is just a two-person or two-subject block. All right. Now you are going to work with your groups from the other day, but hold on, don't move yet. You are going to design both a match pairs design and a two-sample design for this scenario. I will give you a little bit of guidance to get started. Do not write this down. This is not something that you need to write down. This is just me kind of getting you started. Matched pairs. Okay, y'all, can we please focus?
Yeah, we need to focus right now.
So with matched pairs, you have your subjects, and then you have to match on some criteria. You are the one that decides what criteria that is. Then you would do some sort of random assignment. You need to describe what the random assignment is. Then you would have your 2 treatment groups. You need to say what those treatments are. Okay, now, if we're doing matched pairs on the back end, what must we do? Can we just take all these treatment A's and treatment B's? We have to do what? We have to match them back together.
Okay.
So match back together. And then you would find your difference. And then what would you do with your difference? Yes, find the mean. Okay? So that's kind of starting for the matched pairs. Now let's talk about the 2 sample. So the 2 sample, the subjects are not going to be matched before they go. They're going to go straight into the treatment groups with some sort of random assignment. You must say what that is. Again, you must say what your treatments are. So I'm kind of just repeating the same thing here. But here, do I need to do any matching back together? No. I would actually just get the mean here, the mean here, and then I would find the difference here. So guys, that's kind of a good way to think about it. That's why we're doing this activity. It's going to get you to get your mind around what is a match paired scenario versus a 2 sample. Let's do it. Y'all are going to get in your groups and you're going to do this activity right there.
What group?
Wait, we're not supposed to write that?